Let's take first a look at the project file where we have an entry for piping and its different disciplines like heating, cooling, domestic water, sprinkler, gas, and drainage. Here we can extend the menu trees and see everything that is controlled by the project file, including systems, calculation methods, and all the product categories that we can use. We take an example like a zone valve. We collect products that we want to use in the project, and this is where we can also go and pick up new products into our product bank, for instance, from our cloud environment. We constantly update our products. So here we have the option to browse the updated products. If there are like some product information that has changed, we can update those products directly into our project file. Let's do some filtering here. For instance, according to the valve type, balancing valve here, and maybe a manufacturer. These figures here giving us the number of products that meet the filter criteria. And here we can take a look at the product leaflet with its technical data and geometry. Inserting of the product happens here by clicking, after which we get to type in the user code, let's say zone valve 1, and maybe the symbol that we want to use for that, as well as some product-specific variables. Let's click on OK, and now we can close down the connect here. The new product is available for us to be used in the project now. Let's close the project file and let's see how we install some products into the project. When it comes to piping, we have because there are a few different disciplines, there are a few different product types or product categories where we fill in different information upon inserting the products into the project. So let's begin by taking an example on domestic water and drainage device. We can install both simultaneously, like attached to each other. We can here choose if we want to install both. So here we could now take an example, a regular basin tap, and maybe we want to pair it with a wash basin. So the list of products comes from the project file. And we want to also align the products so that they go well together when it comes to the distance. So we could, for instance, type in here approximately 50 maybe, so that the tap is correctly aligned here where it should be. We select the placement, and then we get to the installation dialog where we select the systems, tap water and drainage, and the installation elevations. If we put this into, say, 800, the drainage device, let's put this into 950. And clicking on OK installs product. And in the 3D view, you can see how it looks like. In heating and cooling side, we have, for instance, fan coil units. And with these products, we can type in here a desired power output, according to which then a flow rate is calculated once we select here is the system, so we can see a bit how the performance of the device will be and where the operation point goes there. Clicking on OK lets me do the installation, and here I have some options to choose from. If I want to rotate the product, I can do that with the, for instance, with the quick rotate, so it turns 90 degrees, or with D, decide the direction more specifically. And once I click on the spot where I want to install the device, I can here select the installation elevations. if I know where a ceiling goes, I can just type in the elevation there. The system we already chose. OK, finalizes the installation. In the product, we also have a handle, the asterisk. We can use to create another instance, the same product. One more example on drainage side. This time we choose not to install any domestic water devices, but just a drainage device, a drainage connection. The same options here. OK. Now we have installed a few terminal devices, fan coil units, a domestic water device, drainage device, and a drainage connector. And now we can start drawing pipes. Let's first go into the project file to take a look at the pipe series that we can define here. We have those in two different places. Pipe series for all the other systems than drainage, and for drainage here under its corresponding section. And what we can do here is we give some basic information here, like the description and user code, and more importantly, also the calculation related information like roughness values or thermal conductivity. So we can run sizing and pressure drop calculations for the pipes. We define nominal sizes, inner, outer diameters, valve sizes, and what the bend radius is in relation to its diameter, and reduction lengths, or what is the minimum pipe length in between two fittings, as well as the reducer length for different sizes. For drainage series, there is also a length defined for the pipe in between two 45-degree bends, so we don't get 90-degree bends there. Here I have supply and return pipes for cooling. The different options for pipe drawing I have here, either a double pipe drawing or just for one system only. For heating cooling systems or for domestic water, all the three pipes, cold, hot, and circulation, can be drawn simultaneously, or then with whatever combination user wants. For drainage pipes, their own, and gas for their own. So when I take this supply return here, the pipe options dialog pops up, and lets me choose the pipe series that I want. That comes from the project file, size. Also, if I want to use some insulation already here. And here you can see the preview. So if I choose a little thicker insulation here, they might collide here already. So this preview shows you that. So we can maybe, if needed, adjust the distance between the two pipes here. For branches, we have two options here, either 45-degree angles or 90-degree, and branches with a color or T-branch. So let's collapse that dialog a bit and start drawing first from selecting the supply and then return. And now actually this design option conflict dialog tells me that the pipes that I selected, they do not have any insulation, but here instead I have insulation, so now I get to choose that which setting I want to follow. Let's change the active setting now with OK, so that we will keep on drawing without insulation. And here you can see that the insulation option is now empty. So when drawing pipes and when doing product installations, it's good to make sure that the snap functionality is on. So it's easier for us to make device connections and also connect open pipe ends to each other. Here, while the drawing command is active, I have a number of different options here. I could, for instance, install a component here plug the pipes, make a riser, insert a valve, or make an elevation change. I will get the same options here with the right click. So let's make a elevation change here now with the Z. We're in 3000. I will type in here something, let's go down to 2600. Here in this 3D view, we can see how that looks. And now that we are making a right turn here, our pipes might collide. Depending on which turn I make, left or right, my pipes might collide. But here in this routing option, you can see that I can keep my supply pipe above. So let's do that and draw the pipes like this. And in the 3D, you can see how they go. Now that I have my snapping on, I can see that when I draw the cursor, it aligns with the return. Here in these Fangoal units, the connectors seem to be like a bit unsymmetrically, so I am not able to align the pipe end perfectly, but it seems to align with the return. So I can draw the pipe here. And if we notice that we need to make some changes in elevation, for instance, we can do that in plan view with the move function. In this case, we can select the pipe on top, the supply pipe, and down here we can see the options. Now we would like to change the elevation, so we'll select Z, move the pipe, and here in the 3D view you can see what happens. Let's do the same for the return pipe. We'll lift it a bit higher, like this. And now, connecting devices, we have a couple options. We can start from the device. When we click on the connectors, the arrows, we can see the plus icons here, and we can here start drawing pipes, and you can take a look at the 3D view. We can start drawing pipes here from the connector and go to the position where the open end is and click there. Here the design options conflict says that we have the main pipe here and the connection pipe are of different sizes, so we can accept that and see how the connection is made there with a slight drop in elevation. And we can do the same for supply. And having the smart option there, we can click on the main pipe and smart option make sure that we get standard angle bends. Therefore, we can do connections directly from the main pipe to the device. For instance, by clicking on the asterisk handle here, create similar. That is, now we don't have to, having the smart option on, we don't have to worry about where to click on the main pipe. Just so we click there and click on the connector and OK, it makes the connection. And the same for return. There. Here you can see the connection. Let's take a look at how drainage pipe is drawn. We select here, in addition to the basic series selection and size selection, there is the fall, which can be defined here, and also the direction of fall. And in this case, it's good to use the smart routing, meaning that we won't get the 90-degree angles here for drainage. But otherwise, it goes in the same way that with first click, we get to set the system and the elevation. And in the 3D, you can see what happens. You can see that now that I draw a bend, MagiCAD draws two 45-degree bends instead of one 90-degree bend. And clicking on the pipe, we'll get to see the elevations here, the both ends and the fall. And the length of this pipe between two bends is 150 millimeters. That is defined in the project file for each size separately. Connecting, like in this case the siphon, the lower connector here is directly on the 0 level. Clicking on the component, we'll select the plus icon where we can start drawing the pipe. And now we have the same fall. Starting point is 0 of the story level. What we could do here is we could right click, select Z, and inherit the elevation from the main pipe here. You can see the updated elevation information. Click on OK, and now directly click on the pipe. Take a look at the 3D view, what happens. A dialog pops up giving us a notification that the pipe sizes are different. We'll click on OK, and here we can see that the connection is made to the correct flow direction, and here the small piece of pipe here in between two bends, 50 millimeters, as defined in the project here. Also here we can make small, if we needed to change elevations afterwards, after we have made connections, we can take the set and here see the how it looks in the 3D preview, and maybe make small adjustments here if possible. Let's take a look at how to connect a domestic water tap. I have here cold water, hot water pipe. So what I can do is here to start the multiple pipe drawing. I have here cold and hot, after which I can choose the routing that I want. I could check what the connection size of the tap is. Let's say if it's 10, I can choose the pipe series and the sizes, and branching off from the main routes, I might want to do an elevation change. Let's say 90 degrees and 80 millimeters. Then I need to decide the routing. Here the cold water pipe is the so-called cursor pipe. So that is what we look at when drawing. Going downwards here, I have the hot water pipe closer to the tap here. So first I will click on the spot where I want to start the drawing, and then I will click on the hot water pipe. Design options conflict just tells me that the sizes are different. That is okay with me. I will keep the active settings here from the dialog and click on OK and draw the pipes. Now with the snap-on, I can draw the pipes on the same level with the connectors in the tab here. You can here see in the 3D that the elevation change has been made. And with the right click, I can choose to go down to, let's say, 150. So this is the cursor pipe elevation, which is the cold pipe. And then I will click on the cold water connector to make the final connection. And that's how it looks like when it's connected. Connecting radiators can be done in a couple of different ways. Here I am approaching with double pipe drawing, having the smart routing on. I can here remove the insulation, so there will only be insulation in the main pipes here, but the connecting pipes will be without. I can here, having the smart on, I don't need to come closer, but I can directly, for instance, choose the radiator valve further away and just have the valve inside the yellow search circle and click. So the software will route my pipes and connect them with 90-degree angles. Here the design option conflict says that the connection size will be different than the active selected pipe size, so that is okay. and I click on OK, and here in the 3D you can see how the routing is made. And the other radiator, I can also begin here from the valve, click on it, and select both the pipes that are on top of each other like this, and the same size conflict dialog appears, and I'll accept it, and the connection is made. Now we have drawn pipes, we have installed devices, and we also got some dimension text tags placed here. So we can take a look at the editing tools that we have: copy branch, crossing, and how we can in general modify the networks once we have drawn them. Here, for instance, we can see that there are probably some collisions in the network. So therefore, we can use this collision control to check the places where we might have some issues. In this case, let's limit the collision control a bit by selecting pipes against pipes and drainages, and drainage pipes against drainage. If I had a 3D model, I could include some architectural structures there as well as objects from external references. But I will just run the collision control now as it is. OK. And for this example, I will choose this area here. And I will a report opens up for me where I can zoom in and mark the collisions, and here we can see that yes, indeed, we have to modify the network a bit. Therefore, we could, for instance, use the move tool here. If we can make some minor modifications, move the pipes around a bit, maybe take the return pipe now and slightly move it towards the fan coil units to make room for all the pipes. And here I can just decide where the new position of the pipe run should be. We can see that now there is a slight gap. And if we run the collision control again, we get it verified that no collisions are found. But it's not always this easy. We might have to take other measures like crossing. Like here, we have pipes going through each other. Therefore, we can select crossing. Let's say we will take the supply and return and go over the domestic water pipes here. So therefore, I would click on the first point and the second point to mark how long the crossing will be, and then I would include the pipes that I want to apply the crossing for, and last, a reference point, the obstacle elevation here. So I will just click on one of the pipes, domestic water pipes here. And here we can see how it looks like. We could also choose to go below the domestic water pipes here. Let's go over like this. And if there is no room for a certain angle, then we'll get a warning about it. And OK accepts the crossing. So we don't have to split the pipes and draw again, but we can apply a crossing like this. Moving forward to editing tools, so we might need to add some insulation, for instance, to the pipes. That we can do here in the change properties. We have here heating, cooling, insulation series. We'll select the correct one, and for instance, with the manual selection here, I could choose, for instance, the between option, typing in E and selecting 2 points between which the selection is made, and with enter the insulation is added. Furthermore, we can do some minor modifications here. For instance, the partial insulation. We might not always add insulation with the whole pipe. There might be some gaps like this. Maybe there are some pipe is going through a wall or something, and we don't have the we don't want to have the insulation everywhere. So, and here as an example, 3D rotate of valves, for instance. If we need to modify the installation orientation, we have the 3D rotate for that purpose. And another tool that speeds up the design process is the copy branch. So let's say we have here a ready-made branch with a device, with a valve and dimension texts. So therefore we can, with this copy branch, we can take all of them at once and install it somewhere else as such. We include the T branches and the connecting pipes. There now all the segments, fittings, valves, and dimension texts follow along. Place this Fangoil unit somewhere else. Rotate it, and connection point of supply pipe here and the return. So even if the main pipe is not identical, we can still make the connection there. Now we have drawn pipes. Now we have installed some devices, drawn pipes and connected them. So we can take a look at how to install components, for instance, valves. So here we can go to the valve section here. And in the dialog, you can see all the 5 different valve categories where we can choose from. And in case we have a fan coil unit here, we could select a zone valve here and select a suitable symbol as well. Now we don't have to mind about the sizes because the size will be inherited from the pipe. First, we click on the pipe, and in the 3D view we can see here that when we rotate the cursor around the valve, it goes either, the installation happens either up or down. And we want to install it downwards, then we can click to complete the installation. Manifold is another example of components. There are both real products and generic ones where you get to decide the size and the number of outlets and rotate it as you like. But the installation is still very much like devices. And you can select the system, the main system, domestic water, the system type, and inherit an elevation from the pipe, for instance. And now that we're using Snap, it's convenient to connect the pipes together. And from here, you can continue connecting the manifold to the tap, for instance. Component installation can be done also using the right-click menu. We go down to 150, for instance. And here, taking right-click, we can choose the component installation here behind the menu and install an expansion tank. Now that we have completed the networks, we can take a look at the calculations. Let's take a few examples on hydronic network and the domestic water network, both for sizing and pressure drop. But let's first take a look at the project file. Here for heating, cooling, and domestic water. First, here we've got the sizing methods. User modifiable sizing methods can be either pressure drop based or velocity based, and for domestic water as well. And these methods are then assigned to the systems here for cold, hot, and circulation, and some pressure level minimums or warning limits as well there. And for heating, cooling, in the same way, we define the sizing method that we want to use and the pressure drop method as well, with some minimum limits for valves and devices. As well, if there's a pump in the system, we can choose to calculate to that. So let's close this one and let's begin with sizing. Here, first, let's take the cooling, the fan coil unit network here. I run the sizing by system. So here I select the cooling and I select show calculation report, and then I click on OK. What happens here? I get the report. Preview shows the network. Here in this old size column, we have the size that we have drafted the network with, and here on the left side, the calculated new size according to the sizing method that we have selected, with the power from the fan coil units and the calculated flow rate accordingly, as well as the temperature drop across the network. So this report gives us a transparent overview on what is happening in our network, together with general results with the fluid type and its characteristics, and both for supply and return systems. And OK, update to the model, then pushes this new calculated size into the network. After this, we can run the balancing, the pressure drop calculations. We can see here we've got zone valves here. They don't have any pressure information yet and no kV value, but now we have sized the pipes. So after this, running balancing, the valves will get their correct values. Now in a similar report, but with here in the root, the total pressure level, flow rates, velocities, and the same pressure temperature drop going on here. On the return side, we've got valves. Here they get their adjustment values calculated, and this is a report where we can check some product properties and the operational points for valves and their adjustment values. Update to model. Now we can see the dimension texts get updated according to the calculated information. And for domestic water, likewise, we can run sizing. This time we select water systems and the system that we want to calculate and show calculation report. And the sizing methods coming from the system as we defined here in the project file. OK, and in the same way we can see the calculated size and the old size. And if in case there were any warnings, such as here in this section, the max velocity being 2 meters per second, we are exceeding that, so we would need to do some modifications in the network to keep the velocities under the defined maximum. In addition to that, we've got cold, hot water, and circulation water network as well there, with the same information, the total flow rate from all the appliances and the calculated dimensional flow. Update to the model now pushes again the sizes to the network, and the warnings are again highlighted here and with these yellow crosses. We can run the balancing as well to the domestic water network, so to get to see what the what the flow rates are for each appliance here with the inlet pressure that we've got here in the root. The unconnected outlets in the manifolds are highlighted. For drainage, we have the flow summation. Now we have drawn pipes, we have installed devices, and we also got some dimension text tags placed here. So we can take a look at the editing tools that we have: copy branch, crossing, and how we can in general modify the networks once we have drawn them. Here, for instance, we can see that there are probably some collisions in the network. So therefore, we can use this collision control to check the places where we might have some issues. In this case, let's limit the collision control a bit by selecting pipes against pipes and drainages and drainage pipes against drainage. If I had a 3D model, I could include some architectural structures there as well as objects from external references. But I will just run the collision control now as it is. OK. And for this example, I will choose this area here. And I will report opens up for me where I can zoom in and mark the collisions. And here we can see that, yes, indeed, we have to modify the network a bit. Therefore, we could, for instance, use the move tool here. If we can make some minor modifications, move the pipes around a bit. Maybe take the return pipe now and slightly move it towards the fan coil units to make room for all the pipes. And here I can just decide where the new position of the pipe run should be. We can see that now there is a slight gap. And if we run the collision control again, we get it verified that no collisions are found. But it's not always this easy. We might have to take other measures like crossing. Like here, we have pipes going through each other. Therefore, we can select crossing. Let's say we will take the supply and return and go over the domestic water pipes here. So therefore, I would click on the first point and the second point to mark how long the crossing will be, and then I would include the pipes that I want to apply the crossing for, and last, a reference point, the obstacle elevation here. So I will just click on one of the pipes, domestic water pipes here. And here we can see how it looks like. We could also choose to go below the domestic water pipes here. Let's go over like this. And if there is no room for certain angle, then we'll get a warning about it. And OK accepts the crossing. So we don't have to split the pipes and draw again, but we can apply a crossing like this. Moving forward to editing tools, so we might need to add some insulation, for instance, to the pipes. That we can do here in the change properties. We have here heating, cooling, insulation series. We'll select the correct one, and for instance, with the manual selection here, I could choose for instance, the between option, typing in E and selecting 2 points between which the selection is made, and with enter the insulation is added. Furthermore, we can do some minor modifications here. For instance, the partial insulation, we might not always add insulation with the whole pipe. There might be some gaps like this. Maybe there are some pipe is going through a wall or something, and we don't have the we don't want to have the insulation everywhere. So, and here as an example, 3D rotate of valves, for instance. If we need to modify the installation orientation, we have the 3D rotate for that purpose. And another tool that speeds up the design process is the copy branch. So let's say we have here a ready-made branch with a device, with a valve and dimension texts. So therefore we can, with this copy branch, we can take all of them at once and install it somewhere else as such. We include the T branches and the connecting pipes. There now all the segments, fittings, valves, and dimension texts follow along. Place this Fangoil unit somewhere else. Rotate it, and connection point of supply pipe here, and the return. So even if the main pipe is not identical, we can still make the connection there. Now we have installed devices, we have drawn pipes and installed components such as valves, and we can take a look at how to place dimension texts on different objects. Let's go first and open the project file. We have here for each discipline their own dimension texts, groups and formats. So if we first take a look at these Fangoil units here, we go to the heating cooling section here, and here we have dimension text entry, and we can define dimension text types for each object category. So let's go to the Fangoil unit, for instance, and here how this works is that we select the properties that we want to tag. In this case, it's object ID, and we can search for the available attributes and properties here from this list. And we select it and define the visuals, what kind of reference lines we want to use, or none at all. Let's keep just the baseline. For Fangoil units, I have defined that their dimension text consists of the object ID that I have defined for them. And for each category, we have different tags. And we're also going to use this zone valve text type to tag the valves here. And there I have selected flow, pressure drop, and the kV values and the user code. So let's see how they look and how it goes about when placing the texts. Here in the annotation section, we have all the text tools, and when I click on the dimension text, I can directly start clicking on the objects here, and because I had defined the active one, so that is what I will get. And here we can see the user code, the system code, and a running index number, that which is the object ID that I have previously given for this product. We can move on to tagging pipes. I have two pipes here on top of each other, and when I click once, I can select which one of the two I want to tag. But here, looking at the command line, I have different options. I can choose add part, so I can also include the other pipe in the same tag. And there I have now the system code and the size as attributes. Also for valves, here, depending on if we have run the calculations for valves, the software again asks me which component I want to tag. I will select the zone valve, and for this valve I have run the calculations. So there we have a flow, pressure drop, and the kV value. But for this pipe, we don't have that information yet, so that will update once we run the calculations. Let's have a look at how we can create bills of materials or bills of quantities. First, we'll open the project file. Here we've got the report templates section, and we can start modifying a template. First, we have to define and include the components that we want, the product categories, let's say valves in this case, and then pick the attributes, properties that we want to include in the report. Here we've got already system name, part type, and product code, but let's go and add one there, let's say kV value. And pressing the arrow will add it in the report. Okay. And here we can still change the internal order of the properties. Let's click on OK and close the project file. Now here, up here, we've got the report tool. We get to select the template from the project that we want to use. We can decide how to present it. This time we will create a block in the drawing so we can add it in sheets if we want. We could also have a dialog pop up for us or maybe export it in Excel directly. But let's create the block now, and I will run it for the current drawing. And click on OK. Now, because I want to add it in a sheet, I might need to scale it up in size a bit. So I will press S and define the scale factor, let's say 20. And now that I click in the drawing, the report appears. And here we can now see the valve types that I have in this current drawing with their device count number. And obviously now if I make changes in the drawing, let's say I remove radiator valve there, I have the count number, there are two. I can go on and update the report. I select the one that I want to update and press enter. You can see the radiator valve count go down to 1, and if there are other components that I have added, they will appear in the report.